Welcome, everyone, to Securing the Joy of Gaming. Um, most of the people here are probably interested in learning about security and gaming in one shape or another. So I will do my best to spend the next hour in delighting the folks about how we do things on Xbox and Microsoft and try to impact some nuggets of knowledge on how you might want to secure your games and platforms going forward. So, to start with, my name is Timmy Adebambo. I am the GM of Gaming Security at Microsoft Gaming. I've been here about 50 weeks now. Um, Started last year, and before that, I spent 4 years at Amazon Web Services. And prior to that, about 15 years in consulting across Deloitte and PwC. My entire career has been in security. I started off with consulting as a teenager. So I've been basically doing cybersecurity my entire, longer than half my life, which is not that long either. But I love cybersecurity. I'm a nerd at it. I enjoy talking about all kinds of security topics. And gaming has always been a passion, like most people in the audience. I love to game. Um, it's not a Microsoft game when it comes to my favorite. It's EAFC 25, but I do enjoy some of our games as well. So on the personal side, if you think you're good at playing EAFC, I'll take up a challenge any day. All right. Moving on to our agenda today. We'll be talking about what are the top security risks that exist out there. Then we'll move on to some of the considerations that we have for gaming. Talk about the industry and what makes it really different. Then the Secure Future Initiative, I'll go into that a little bit. One of our most important initiatives around security at Microsoft and how that impacts our gaming environments. Then I'll also talk about fortifying games and all the efforts that we do and what we think are some of the best practices around fortifying games. Next, I'll talk about the gaming infrastructure itself, our platform, the things we do to make sure that our platforms stay secure. Then we'll talk about the scale of the security threat and why any of this matters, and what we see on our side that makes this a very important initiative for us and a very important responsibility in securing the joy of gaming. And then lastly, I'll leave everyone with some notes on ways to mitigate, if you're a developer, ways to mitigate security risks, some of the top things that we think you can do to really lower the risk of a threat actor. Now, most people don't actually know the portfolio of Microsoft Gaming. I'm confident in saying this because I know many people on my team don't even know the full portfolio of Microsoft Gaming. So on the screen, you'll see most of our important business units, Activision, Bethesda, probably recognize a lot of the games from these studios. Activision with like Call of Duty and Tony Hawk out there, Fallout from Bethesda, got Doom, got Blizzard with World of Warcraft, Overwatch, Diablo, Candy Crush from King, Mojang with Minecraft, and Xbox Game Studios with a number of game studios under that umbrella. That includes Gears of War, Halo, and a number of other franchises. Underneath all of this, of course, is our Xbox console and our Xbox Live environment and lots of other supporting elements of it, safety and security, support. So the portfolio really spans across a lot of studios, platforms, and support services. Overall, we have over 20 first-party franchises that have each attained more than $1 billion in lifetime revenue. And a lot of these franchises have huge followings, huge communities around them. So when we talk about securing the joy of gaming. Our efforts really are to really make sure that a lot of players out there that have spent an amazing amount of money investing in gaming can actually enjoy their investments. And so it's a huge responsibility from the Microsoft and Xbox side to make sure that this experience that they expect when they play any of our really first party games or even third party games on our platforms is a pleasant experience. So, as I said earlier, we'll start with some of the top security risks. You might be familiar with most of this. I'll start from the very top. There's obviously the evident data breaches that has occurred at many organizations, and this is one of the things that we have to safeguard against to make sure that we don't get in a situation where confidential material, which may compromise future game releases and information around IP gets leaked out. And this would be the same for any developer or any studio. Having your confidential and IP being secured is of paramount importance, and we have to make sure that this doesn't get leaked. Denial of service. This is huge. As a player, you definitely do not want to experience wanting to play a favorite game and then finding out that you really can't do it because the system is down, the service is down. So we got to make sure that that's something that we're watching out for, making sure the attackers don't overwhelm the game servers, disrupting the traffic and things like that. Ransomware has been very common over the last few years. Ransomware is on a rise. We are seeing ransomware actors very prevalent, not just in gaming, but across the technology spectrum with an attempt to really encrypt the data or extort the organization after encrypting the data. And that is something that we also trying to actively make sure doesn't happen in any one of our environments. The one at the bottom there, insider threat, may not be as obvious, but from time to time, employees do act maliciously to either attempt to leak data for various reasons, part of an underground community, or just out of spite, for whatever reasons. They do decide to act against the will of the organization, and we have to be able to identify when things like that are happening because ultimately they could disrupt services, they could leak information, and they could try to do things that are harmful to the ecosystem. Then in-game cheating. Um, this is very, very prevalent. It's grown to be a greater than $50 million industry where hackers develop and distribute cheats and bots and all kinds of exports to try to manipulate the games. Oftentimes, we find that when these types of exploits are available, the game doesn't get the traction among the fair players, and audiences drop as everyone starts to leverage the exploit, and it doesn't feel very balanced. And really, the revenue for that game, as well as the impact the game would have on the customers, is really going to be a negative one. So we have to also watch out for that. So these are some of the things that we really have to try to solve with a gamut of tools and people and processes, which I'll go to next. So, what makes gaming different when it comes to security? I mentioned DDoS earlier as one of the denial service as one of the key things. We're very prime top target for DDoS because we run 24/7 live services. Um, if the service is down, unlike many other parts of businesses where the Hyatt hotel can be down for like an hour and they'll probably still function, it might not even make the news. If the servers of Xbox Live are down for an hour, it'll be all over Twitter, it'll be everywhere, and players will be talking about it, they won't be able to play the games. And the inverse of that is that attackers know that, and they know that if they're able to really compromise any live service, not just ours, but any live service, it really becomes a situation where they have more cards in their play than if they were to do it to someone that has hours and days to respond to it. So it makes gaming a huge target because 24/7 player environment is something that we basically live on. Um, Player personal data and financial data is also something we collect. Most game platforms today require a credit card to download the game, to buy upgrades. So oftentimes you find personal data, you find the names, the address, the telephone number in the profiles, but you also find credit card information, which is oftentimes valid and active. So when you're looking at that and you see something like, oh, Microsoft Gaming has 500 million active gamers every month, well, that's potentially 500 million credit cards that you could, get your hands on and see what can happen. So it's really like a huge financial and personal information data trove, and that makes it also very, very attractive compared to some other businesses. The next one, real-time transactions. Um, Transactions happen all the time, like every second. Someone's buying something, someone's doing an exchange, downloading something. As a result, the ability to intercept one of those transactions, because of how many they're happening not just in one country, they're happening all over the world, in every corner. The ability to intercept one of those and take advantage of it, and be able to quickly make purchases after you do compromise that account and get things that are valuable is very high. And so that's one of the risks that we also face in the industry. The last one is interesting. It's the co-dev partnerships. Unlike a lot of other industries, a game is usually made up of like several partners. We have small partners that maybe a 5-person shop that is just animating a dragon in Santa Monica, and you have someone else doing the publishing, you have someone else, doing the sound. We have so many pieces that have to come together. When you combine that with, then we got the servers and you got the platform, there's just all the different pieces. And oftentimes when you have that level of complexity, what happens is that there are gaps, right? There are gaps in the connectivity from every one of the partners. You're depending on some code from a different vendor, and that vendor has to interact with you. You have to make sure that their authentication is right. You have to make sure every vendor that you're dealing with has the same level of security, which oftentimes can be challenging because maybe they don't, but you really do like their product. So it does create a unique challenge within gaming to try to address the security across all of our co-dev partners. And that's one of the, I would say, really unique things that over my career, I haven't seen as much collaboration to make a single product as I see within gaming. And so it's definitely one that creates specific challenges for us. All right. I'll talk about the Secure Future Initiative a little bit. It is a multi-year commitment from Microsoft to make sure that we operate and we build solutions and applications at the highest level of security and set example for industries. This started earlier last year, almost a year. I was going to say earlier this year, but started last year. And it's really operating on three principles. It's secure by design, which means that from the very beginning of any product or application we're building, we are incorporating and thinking about security in its inception. I'll go into some examples of how we do that with things like threat modeling, but we are thinking about security from the very initial stages of architecture. The second is secure by default. This means that applications and products that come out of Xbox and Microsoft at large should be secure by default without the user requiring to do things to make it secure. So the native behavior should be in a secure state rather than an open state that then we have to secure. The last being secure operations, which establishes a set of operational guidelines and processes that keeps things running in a secure state and alerting to make sure we know when things are out of those bands. So those are three fundamental principles that really change the way Microsoft builds games, applications, tools, and generally all our technology. Within gaming, that means that we have to address the games and the platform with the same lens that I just mentioned. For the games, as I said, in the Secure by Design, we start with threat modeling. I imagine that most people know what threat modeling is, but um, for the for the sake of just going back, if you already know what it is, just pardon the 2 minute spiel. But threat modeling is a process where we look at all of the various risks that the threat actor can pose to an application based on the way the application is designed. That means we look at everything from the infrastructure, whether it's in the cloud or it's on-prem, and all of the connectivities to it, as well as inside the application itself, the way it's designed, the open areas where compromise could occur. And the next step is to take a look at all of those items and figure out what are the mitigations that we can design or develop, or at the worst, accept if we decide that it's something that we're willing to live with. But the process of knowing that in the very inception, a very early stage, enables us to then build controls and mitigations throughout the life cycle of that game. And that's a very important process that we want to do for every single game very early in its life cycle. It's one of the very first things that we want to do once we get an idea. And I also want to say, threat modeling doesn't necessarily just stop in the early stage. Over the life of a game, especially with games taking 3, 4, 5 years, ideas change, and there could be significant changes from going from a one-player game to a multiplayer game to a live services game. All of those types of changes introduces new threats and new opportunities. So we have to consider whether the game has changed significantly from the last time that the threat model was done, and then we evaluate it based on the controls and the risks that we see. So threat modeling, huge part of what we do to make sure that our games are secure from the design perspective. Then I'll go into security testing next. We do a few tests around security for our games. The very common secure application testing, SAST, as well as secure software composition analysis, SCA. And the difference between this is secure static analysis security testing really focuses on the code that we're developing. Do we have vulnerabilities in that code? Do we have APIs that are unauthenticated that we have in there? Do we have what we have as the OAuth substand application vulnerability? Are they vulnerable to things like SQL injection? Do we have unvalidated inputs that could lead to cross-site scripting? Those types of things that are obviously covered within our static application security testing. And then, as most games are made, they often depend on libraries that exist already, right? Developers don't make the game with all fresh new code. Oftentimes, you depend on existing functionalities, existing libraries, existing code bases. So when the game comes together, our SCA, software composition analysis, really looks through all of those libraries and checks to see that we don't have vulnerabilities that have been brought into the game from those libraries that are being used. And he also looks to see whether the way all of them come together really creates new risk for that game that we're trying to develop. So that's very important. One other area that we do test sometimes is the infrastructure as code. Not all our games are necessarily built on the cloud. When they are built on the cloud, infrastructure as code is a very common way of deploying the cloud application. And that also could be vulnerable to security risks. So we definitely do scans on infrastructure as code to make sure that that is also pretty well established. The next one is the AI-driven secrets and credential scanning. We've been doing cred scans, credential scan using Microsoft Cred Scan for a while. In the last few months, we have supercharged this with some AI capabilities to help us not just detect, but also eliminate some of the false positives. We've noticed that false positives can slow developers down. One of the things that developers hate from the security team, for those of you that are on the security side, is seeing a bunch of alerts that when they look at, they're like, well, this is not real. It really does erode the confidence and trust from the security team. So one of the things that we're trying to do is take a lot of those noisy applications, noisy alerts from security testing applications, and pass them through AI-driven software that can help us with the false positive reduction to be lower. But underneath all of this, the core thing that we have to do is identify secrets in our code bases, because we don't want secrets to be shipped out with our games, whether they're passwords or authenticated tokens. We want all of those to be leveraging a secure vault. And all of our studios have several vaults that are established for secrets. But we do find that sometimes developers, whether it's out of habit or for whatever reason, still put credentials in their code, and we try to extract that and find where those are, and then reach back to them. And some of it includes some education around the best way to really incorporate the authentication into the code base. Next is the proactive game penetration testing. We strive to complete pen tests as often as we can, with a target of making sure that all our top games are at least tested on an annual basis. And what pen tests really do is go one step above the static analysis and the tool-based scanning, and really puts a human behind it, and puts on that put on that mentality of like, if I'm trying to attack this, if I'm trying to take advantage of this minor vulnerability or this accepted risk within this game, how could I leverage it to really do more damage and really compromise it? So we have a team that spends some time for each game in that development life cycle before the games get released, and even after the game is out, to make sure that additional vulnerabilities in the code base that are found are not really usable to compromise our games, and the exploits are not valid. Because if they are, then the penetration testers will validate it by actually, going through that and being able to be able to call it back to the developers to fix. The last is anti-cheat. Our games leverage a wide variety of anti-cheat. We don't leverage just one singular company. We do give our studios flexibility on the different anti-cheat technologies. A lot of anti-cheat technology works well with code scanning, because at the end of the day, it's really looking at exploits, trying to exploit the code base, trying to exploit something in the game to really create that advantage with that cheat package. So we leverage different anti-cheat technologies and incorporate them to make our game safe. That's on the latter hand of it. But if you look at it from our SDLC, what we've really designed is a gaming SDLC where throughout the life cycle of a game, there's definitely some security steps that needs to be taken. And at each step, we're gaining more confidence and reducing vulnerabilities throughout the game development life cycle. Moving on to the infrastructure. When I think about the infrastructure, I'm thinking about Xbox Live. I'm thinking about Battle.net. I'm thinking about Demonware. The foundational elements that really power the player experiences, not individual games, but the actual underlying infrastructure that we support. The one thing that we have to always do on every asset is, well, before all of this, we got to identify the assets. So before we can secure it, we got to know where all our assets are. But once we identify our assets, we have to make sure that we have endpoint visibility. We have to make sure that we can actually detect if there are threats on the assets. So think about anti-malware, think about endpoint detection and response, and being able to block malicious things, whether it's on a developer's laptop or it's on one of our game servers. All of those are very important. Deploying endpoint visibility across our entire stack of servers, containers, workstations is of topmost priority. The middle layer there talks about the AI-driven threat detection. This is where we leverage Microsoft Sentinel and in some capabilities Splunk as well, to really detect threats within the environment. When you have millions of gamers playing on a system and you have millions of threat actors that are trying to attack, it's important to be able to quickly detect threats. The earlier threats are detected, the quicker we are able to act. And the AI element is important for enriching the alert and letting us know that compromise has occurred or something that looks out of whack is happening, and raising all of those alerts. In the next slide, I think I'll talk about the scale of these alerts. But we have a tremendous amount of alerts, and we have engineers that are constantly trying to help us create new detections as new attack patterns emerge. So we have some folks working on the threat intelligence side that are helping us identify, new threat patterns and new emerging what would I call it? Emerging indicators of compromise. That's what I'm looking for. Yeah. So indicators of compromise are being brought forward. Automated incident response. This is a very important element because not only do we need to detect the threats, but we need to respond to them. We need to respond to them very quickly. As I mentioned earlier, the threat of DDoS is very real. So the ability to detect and close and address it very fast is super important. Automation is leveraged on that. We've started deploying security co-pilots to help with the artificial intelligence. We have use cases that we're building to be able to quickly respond to the threat without human intervention and be able to help us with some of our investigation. That's where we believe that we can get some more efficiency and increase our speed in doing incident response. Behavioral analytics. This is also core to some of our detection. We get telemetry from our network. We get telemetry from our endpoint EDRs out there. And ultimately, there are certain behavioral patterns that we can start to identify. If we have a developer that is logging in from California and in 30 minutes, the same developer is logging in from a Chinese IP, that would indicate that the geographic distance is unlikely to have been traveled by that individual. It will raise a likely alert, after which we can actually start to look into that and understand, is it that same developer? Is it someone else that has compromised the identity? And we can then start to enrich the alert with what types of activities are they doing? Are they doing typical activities? Or if someone is typically just logging in and just doing, a set of commands, and the next thing we see, they're downloading a high number of files, they're doing things that they don't typically do. We have the ability to detect some of that with our behavioral analysis that happens on our platform. The last is red team simulations. Microsoft does have a very robust red team for all of our technologies, and we welcome the red team to test our platform. We welcome them to test our games, and this is a really important part of it for us because although we have really brilliant penetration testing that happens, we always like to simulate what do people see from the outside. Like if you were to try to get into Xbox Live and you knew all of our IPs and you even knew one of the credentials from one of our employees, what are you going to be able to get? And how quickly will we be able to detect that activity and stop it? So that's a very important element to the platform testing because we live in a world where we assume breach. We always assume that someone's credential, has been given out, or someone has, clicked on a link through a phishing attack that they weren't supposed to click on. So we live in a world where we assume the breach, and we say, given that assumed breach, what can you do to our network? And how quickly will our blue team on the inside pick that up? So these are some of the things we do on the Xbox platform. These are the core things we do on our platforms, whether it's Battle.net, Demonware, Xbox Live, to really make sure that Xbox is the most secure place to develop and launch games. We leverage a numerous amount of technologies from Sentinel, which folks can deploy, to Security Copilot, credential scanning with CredScan. Legit AI is one of our partners for some of our AI credit scan, CodeQL from Microsoft. But we essentially just deploy technologies in the right places and follow a very secure SDL process, along with secure operations that can help find where threats are within our environments. What does all of that end up looking like in a year? It looks like that. About 3 trillion logged events that occur. And we distill that to about 16,000 issues that we have to walk through. That ended up last year being about 51 incidents, about an incident a week that we actually have to go looking deeply, and 0 public breaches. But you could see how that funnel kind of starts super wide because the amount of threat that is faced by a platform is unprecedented in the AI era. We have a lot of attackers that leverage bots and AI to attack the platform. We have a lot of script kiddies. We have people that try to circumvent the threat intelligence by quickly spinning up new domains, and within minutes of that domain being spun up, before it's identified as a blacklisted domain, try to use that domain to quickly generate some alerts and see if they can compromise the environment. We have people that are constantly scanning our network and IP ranges to see whether we have an open port and things like that. And then finally, what we've realized is that we also have a lot of nation states. It's no longer the days of, some kid with a hoodie in his basement just trying to do some malicious activities. We have well-sponsored organizations in North Korea, China, Iran, Russia that actively are trying to perform some of these malicious activities on our network. So they're well-funded. They have the ability to really do very powerful attacks. They have the ability to maintain persistence. They have the ability to bounce around if we try to identify one of the areas where they're operating and shut it down. They have the ability and funds to really launch the attack from many different geographies. And that really just increases the complexity of what we have to deal with. And over time, we consistently see that the logged events are higher. So while it may be 3 million from last year, we are likely to have way more than 3 million with the advent of AI in 2025 and the increased use of that. Overall, it's important to look at the end and get 0 because that's what our players care about. Our players do not really care about the 3 million attacks. They want to show up, after a long day, play Call of Duty and be happy. They want the environments to be live and valid. And that's what we strive to do. That's why it's very important to take all of those measures and have our teams really trying to just keep the good side of the battle and make sure that we're making none of those attacks really get to our gamers. One more slide to talk about the actions to mitigate security risks. When you think about a lot of the things that I've talked about, as developers, you might wonder, is there really anything I can do? Like, you've talked about an hour around all of the crazy things or amazing things, depending on how you see it, that Microsoft does on the games and on the platforms. But are there any things developers can actually do to help in this fight against malicious activities? And the first is secure coding. Just following secure coding principles, validating inputs, avoid hard coding secrets, authentication strings inside the code. I think that's very important. It's very important to make sure that you're coding in a very secure way and you're following secure coding patterns. The next will be security scanning. Use the updated libraries. Don't just copy old code and paste it in when you're using PHP, 2.0 when we are on like 6.0 or whatever. So keep libraries updated. Scan for dependencies. Depending on the size of your organization, you might have a robust scanner like CodeQL, or you could use freeware that is available to scan as well. But always scan the code, look for dependencies, look for vulnerabilities within your code, and try to improve them by removing some of those gaps within the code base. leveraging authentication, the right level of authentication. So whether that's role-based access controls or attribute-based access controls, you got to have that. And MFA is important for anyone that's doing anything without platform or access, locking things down so there's multi-factor authentication. And definitely secure cookies. No one, long-lasting cookies, they just don't do well. Whether it's in the kitchen or inside code, no one likes long-lasting cookies. So secure cookies, regenerate them often. Don't hold on to like long session IDs. They just don't work well. They create security risk in the long term. And then lastly, secure using encryption. Using a vault, of course, but not just a vault, leveraging strong encryption where necessary, AES 256 for data at rest, TLS for data in transit. Just following these four practices, I would say would probably reduce the likelihood of having a security issue by greater than 90%. I think the reports from Verizon last year showed about 50% of all incidents are related to an identity problem, just authentication. And then beyond that, you start to look at some of these other three. So if you could really lock down on these four elements as a developer or as a development team, most of the elements that we do find relate to the security risk I mentioned in the beginning can be really remediated or mitigated at the early stage of the development lifecycle. Well, that is all I got. If you have questions, I will be able to take them, and I'll be in the Xbox Lounge from till 5 p.m. from whenever this time is. I will take questions there. Happy to take some here since we still have some time before we leave. But if there are no questions there, because I understand it's security, and you might not want to tell me all about your very secure environment in public. So if you want to, talk later, I'll be able to do one-on-ones. But anyone that asks questions right now, I'll be able to do so. What two?
So yeah, thanks for your presentation. Pretty complete. I was thinking about some of the developers that I spoke here in the conference. So these four elements that you suggested, is this a starting point for them, considering they are small and sometimes they don't have a security team? How do you recommend them approaching these things?
Yeah, if you think about the four things on here, none of them really have a high cost to them, and that's some of the reasons why I wanted to really emphasize the fact that while there's ability to do this with a big old team with some AI built in, secure coding really doesn't take abilities that are beyond just following good security practices in coding. And if you think about testing, which is one of the most important elements here, they have freeware that you could use to scan without having to actually pay for it. And even some of the paid vendors are not very expensive in this space. They're fairly price competitive. When you think of authentication, it's oftentimes just a matter of like the inconvenience. Like everyone's probably tired of MFA in their personal life of like getting that text message and checking the email for that code. There's just a level of inconvenience people sometimes associate with things, and that erodes it. Or starting a game off and being like, well, I don't have time to like define all the permissions for this function right now. I'm just gonna leave it wide open because it's early. And then as the game starts to go, they don't go back to like that function and tighten it up. So a lot of it is just like really following those best practices. And I would say it's a starting point. If your developers are doing secure coding, they're doing some level of testing, authentication is built into the way they're doing things, and they're leveraging vaults and using encryption, it's really going to go a very long way in making sure that they're secure.
Hi, I was wondering, throughout your presentation, you brought up three sorts of testing. You talked about initially like proactive
Pen test, proactive penetration testing.
Yes, and then you also brought up that engineers were also keeping an eye out for new attacks and
Correct.
abilities to pass back to developers, and then there's also the red team that
Right?
keeps an eye. So they all work just as a part of your security for a given product, or are they all at different stages? I guess I guess the question I'm asking is that they're all seem to be doing the same thing, or is that
No. No, not at all. Not even close.
okay?
So we talk about the testing initially, like the SAS, right? That's testing the code itself and identifying gaps within the code, right? So I'll cover some of the testing one by one. The static analysis testing, that is looking at the code base that is being generated, new code. Secure software composition analysis is looking at a combination of all of the different libraries that are brought in and looking at the vulnerabilities across all of that put together, right? So the first one, the second one, both of those still on the developer side. Then you're looking at penetration testing, where someone, not a tool now, someone is actually making an attempt, right, with the knowledge of that application to try to get in and create an exploit on it, on the application itself, right? But they know the application, they know the layout, and they know the vulnerabilities, and they're trying to exploit it. And then there's a red team that sits outside, and you might just as well imagine the red team to be the attacker, because really that's what they are. So we basically pay a different team that doesn't have any knowledge of what they're about to look into and give them some credentials, some IP ranges, and tell them, go break it, go do whatever you can, because that's the way the attackers see it. So we want to constantly simulate that and say, okay, what can happen? Go try to take Xbox Live down. Here's the IP ranges, here's a credential, go, have fun at it. And when that's happening, surely since they have a credential, they'll get into something, but then you're testing the defensive capabilities and saying, how quickly are we able to identify that? Did we identify that attack within a minute and then shut it down? And also, when we shut it down, a red team is not just gonna stop, right? They're gonna try to hop into something else. So are we able to continuously, as a defense mechanism, handle that? And that's a different team, right? That's the incident response team. That's not the developer on the static analysis and software analysis. So all of this come together to really secure the platform, but it's not repetitive. It's a different layer.
Okay. So they start with the vulnerabilities in the initial code itself, then stuff that connects to it, like libraries, and then pretty much simulating an outside attacker with
Yep,
limited information trying to get in. Okay.
correct.
Did you answer your question? Given the security landscape now for like small indie games that want to be multiplayer, it seems maybe unrealistic even following these mitigations to mitigate things, say like DDoS attacks. Would you recommend that indie games just kind of give up and go P2P, or is it still realistic to do small indie games with the server?
I think it's still realistic to do a small indie game with a server. I don't think like all hope is lost. I think one of the things that happen is that the bigger we are, the larger the target. So when you look at it from that perspective, an indie game is probably not going to see 3 trillion attacks, and so the level of sophistication they probably need to have to respond to it is probably not going to be at the same. But they still need to have some of those underlining things that I mentioned. Like they still need to be able to understand when an incident is occurring, right? And if they have taken some really good measures around things like authentication, around things like encryption, even an indie game is able to really deploy most of those things because the core security precautions are not costly. Now, when you're operating at scale and you want to detect, and you want to analyze 10,000, attacks within the last second, now you need something that's going to be able to do a little bit more. But I think if you're talking about an indie game trying to run a multiplayer service, I don't think that is something that is unfoundable, especially because we also live in a age of cloud, which means that if you're running on Azure, if you're running on AWS, you are able to leverage AWS DDoS protection, which is still only a few $1,000s last time I checked. And what that enables you to do is allow AWS to scale your server. So as you continue to get hits, AWS will scale your server until such a time that they can contain all of the flood that they're experiencing. So you're able to use cloud-based services. If it's AWS, they have CloudFront. If you're dealing with Microsoft, we have Azure Front Door, and I'm pretty sure Google has something as well. But you're able to leverage cloud-based services to mitigate DDoS on the infrastructure level to also complement the solution.
Thank you.
You got a question on that?
Great questions.
Okay. Does Microsoft do anything special social engineering wise for its employees?
Social engineering wise, so are you thinking about awareness type stuff?
Yeah.
So we do. Whew, I almost sat down there. We do have a team that does what we call security training and awareness. The core aim of that is to try to get messages out to our community, our gaming community, to really help them understand some of the security things that are happening. In addition to that, one thing that we just relaunched is our phishing campaign. So every single month, we actually send an email to everyone in our gaming community, and we attempt to exploit their credentials from them by sending them, hey, free Xbox at the store. Click here to redeem one. We haven't done that a particular one, but I think that one might work. The aim is to try to not just get people to not click it, but to also get people to report. So within my organization right now, we have a target of 25%, because it's not just about you seeing it and be like, oh, delete, move on. Because all it takes is like that one person that doesn't pay attention to like click it, and then they get credentials. So what we want as an organization is not just awareness to not click it, but also the knowledge to report it. Because once a few people report it to our security engineering team, they are able to block all those emails. They're able to now send a new email saying, do not click this. If you've clicked this, respond to it. So it's really about like us trying to simulate that and trying to make sure that like our employees stay vigilant through constant like training and testing them through the phishing exercises.
Have you seen that be beneficial to the employees?
Yes, it's beneficial to the employees in more ways than one, because it also helps them in their personal lives, because phishing is not just at work, right? People are constantly trying to phish. If you look at your Gmail or your Yahoo or AOL, whatever email you got, you probably have people trying to like phish and get information. So I think it's very important for folks to just be aware. So we do the annual security training, but we also send out security newsletters within our community to try to let people know of some of the things that are happening. And then we do the security phishing exercises. Any more questions?
Oh,
Yeah, go on.
how to word this? Have you seen that people actually learn from these, and
Yes.
like next month when that email comes around, they actually report it?
Yes, because I never thought we'd be over 20% report rate, and we are. We are not at 25%, but originally I was like, that's 1 in every 5 employees actually reporting the phishing. But we've actually got into that, and we didn't used to even track report rate. We used to track click rate, and click rate has been as high as 15%, which is terrible. That's like 1 in every 6 people is getting fooled. And we're down to numbers that are, low single digits at this point. So we've seen improvements in both not clicking an improvement in reporting.
Thank you.
Fantastic questions, and we got one more. I think we have time for 2 more questions.
Hi. I was wondering, have you seen any differences in the kind of threats that, for example, PC and Xbox face? Because they are relatively different platforms.
We've seen different types of threats. Largely, I would say no. I think there could be, but from the view of the security engineering team, they just see an asset under attack, and from the view of the attackers as well, they see vulnerabilities or ability to exploit vulnerabilities. So I'm not sure that the types of attacks are actually any different. I have not really looked at it at like the attacks we see on the Xbox platform versus the alert we see on, like game on a PC. Because if you've been looking around, you've probably seen a few things that said this is not an Xbox and this is an Xbox. So the definition of an Xbox is actually kind of changing. So your question on around like on a PC versus on an Xbox, the Xbox is now a PC. So, you know, it's kind of difficult to separate when they're becoming one. But generally, I just, from a security perspective, we just see an asset, like asset under attack by this vector, asset under attack by that vector. I don't really think it's any different. If you want to email me after I like find out conclusively, I'll tell you. But
Last question. Been great questions. Thank you, everyone, for the engagement.
yeah. All right. Thank you.
Thank you.